This is a second example for double displacement reactions that lead to precipitation. We are combining the ionic salt or the ionic solution, aluminum nitrate, with strontium sulfide solution. We first start by writing the components. We have aluminum 3 plus, and we have nitrate 1 minus. We have strontium 2 plus, and then we have sulfide 2 minus. These charges can be obtained by looking at the positions of the cations on the periodic table, or by using group number -8 for the anions. In the case of nitrate, group number -6. Alright, now the charges are used to come up with the proportions. The 3 goes in front of the nitrate, 1 goes in front of aluminum. The 2 goes in front of sulfur, the 2 goes in front of strontium. You still have to go with the lower ratios, right? So even though this will be your initial point, you make sure to reduce it to the lowest point, in which case you only have 1 strontium and 1 sulfur within strontium sulfide. Alright, now the products keep aluminum and strontium in the same positions on the right side of the equation. Oh, and by the way, looking at the solubility table, containing nitrate automatically makes this AQ. Sulfide is one of those ions where you have to be careful. Sulfide is only soluble with the soluble cations or with strontium and calcium. Alright, so you have to, and barium for that matter. So you have to look at the table to assess that this will actually be AQ. Alright, now, being a double displacement reaction means that we will keep aluminum and strontium on the same positions, aluminum first, strontium last, and we simply swap the anions. Nitrate now goes with strontium, sulfide now goes with aluminum. And once again, do bring only the units. Don't bring the subscripts if they're not part of the unit. NO3 is the unit, so that's all that you bring on the product side of the equation. The charge has to also be present because we're going to use the charges to come up with the proportions. Sulfur, same thing, bring the sulfur along with its charge. And now we use the charges to come up with the proportions. 3 plus goes in front of sulfur, 2 minus goes in front of aluminum. 2 plus goes in front of nitrate, 1 minus goes in front of strontium. So what you should get is the following. And since you need to put a subscript in front of nitrate, don't forget to also use parentheses. Alright, now in terms of the solubility rules, anything with nitrate is going to be AQ. So this substance has to be AQ. But over here we have sulfur. Sulfur is insoluble unless you combine it with the soluble cations or barium or calcium or strontium. And since aluminum is none of those, automatically that means that aluminum sulfide has to be a solid. Okay, so this is once again looking at the solubility chart. Make sure to refer to the solubility chart when doing this type of problems. That's the one chart that you're guaranteed to have on the exams as well as the final. So do refer to it. All right, now we're going to balance the equation. We have 2 nitrates on the product side. We have 3 nitrates on the left side. So we have this even odd composition. So we want to cross multiply the molecules by the subscripts to balance the nitrates. Alright, so we will multiply aluminum nitrate by 2, and we will multiply strontium nitrate by 3 in order to balance the nitrates. Now that means that we now have 2 aluminums on the left side of the equation, and we have 2 aluminums on the right side of the equation. So that works out fantastically. We do have 3 strontiums on the right side of the equation, only 1 on the left side, so we place a 3 in front of strontium sulfide. That does change the amount of sulfurs. We now have 3 on the left side, and as it turns out to be the case, we also do have 3 sulfurs on the product side, so the equation is balanced. This is a complete balanced equation. Alright, now we're going to take this all the way to the net ionic equation. In future problems, I will be specific as to whether I want you to go there or not. Typically, I will say, give me the net ionic equation, or give me the complete ionic equation, right? So that way you'll know that you have to go to that extent. Alright, so first things first, anything that's AQ that you see here needs to be split up into the corresponding cation and anion components. Alright, so we're going to go first after the complete ionic equation. And that means that aluminum nitrate, which is AQ, needs to be split up into aluminum 3 plus and NO3 minus, both of them AQ. The proportions need to be kept in mind. You have 2 aluminums, so you better still have 2 aluminums. You have a total of 6 nitrates, so you better have 6 nitrates at the end of this splitting process. For strontium sulfide, you have 3 strontium, so you better still have 3 strontium, 2 pluses AQ on the product on the reactant side, and you also better have 3 sulfide AQs on the reactant side, right? Anything that's AQ, you split up. Same thing here on the product side. Strontium nitrate is AQ, so you split it up. 3 strontiums, 3 strontium, 2 pluses AQ, 3 times 2, giving you 6 nitrate minuses AQ. And since aluminum sulfide is a solid, that you keep the way it is. You don't split that up. Notice that strontium 2 plus AQ as well as NO3 minus AQ is present on both sides of the equation exactly in the same format. These are your spectator ions. And what you do is you simply cancel them out. The resulting equation is what we call the net ionic equation. And what you have left over once you remove the spectator ions is 2 aluminum 3 pluses AQ, 3 sulfide 2 minuses AQ, leading to aluminum sulfide solid. And this right here is the net ionic equation, the only aspect of the equation that actually did chemistry.